Don't forget to subscribe and share. Thank you.
All right, thank you so much for joining us again. So, in the previous video, I mistakenly said this video is going to be on iterated limit, but no, we are going to use polar coordinates. Before the next video, we are going to talk about iterated limits. So, let's look at using polar coordinate to solve a limit question. So polar coordinate is basically maybe having something like this here. So if I have my rectangle triangle here, then I'm saying that now if I have a theta here, and this is my x and this is my y, and then we know the trig functions, right? Sine of theta is going to be y divided by r should be here. So this implies that y is equal to r sine theta. So we need to know this. And then cos theta here is going to be adjacent over hypotenuse. And this is going to give us x is equal to r cos theta. And when you use the Pythagoras theory, we know that this is going to give us x squared plus y squared should be equal to r squared. So these are some of the things that we need from polar coordinate anytime we want to work with limits and we want to use the polar coordinate. I can also square y here and have y squared is equal to r squared sine squared theta, and then x squared is equal to r squared cos theta, cos squared theta. Yeah. So these are some of the things that we are going to use whenever we look at the limit and we say, okay, I think I'm seeing something like, x squared, y squared plus. So let me use the polar coordinate. So examples that we are going to take here is on polar coordinate. So let's start with this example here. So we can see that we have x squared, y squared, x squared, y squared here. So here we are going to use the polar coordinate. So using polar coordinates, now what can we do here? So remember what we just did here, and it's always the best for you to draw something like this if you don't want to memorize that y is equal to this, x is equal to this one too is equal to this. But if you know these three things, anytime you are dealing with polar coordinate, then you don't need this right here. But anytime you forget about it, you can use this one and use the trig properties to derive the identities. So we know that from the table that we just looked at, we know that x is equal to r cos theta and y is equal to r sine theta. And x squared plus y squared should be equal to r squared. Right. So what can we do? We want to change everything here to r and theta, right? So what we can do here is, now we can see that x squared y squared is equal to r squared. But x and y is approaching 0. So if I set, let's assume that I set x is approaching 0 and setting x equals to 0, and y is approaching 0 and setting y is equal to 0. What's going to happen? It means that I'm going to have r squared also approaching 0, right? So that's basically what is going to happen here. Then it means that our limit now is going to look like this. Limit. Now you see that x and y is approaching 0. So that's basically what is happening here. So I use the coordinate here. Let me just use the coordinate here. So x and y is approaching 0, 0. So that's what is giving us this. So now we are going to have r squared also approaching 0. So it's just going to just approach 0 here. And then now x squared plus y squared is equal to r squared. So we are going to have r squared sine of 1 divided by r squared. So this is very beautiful. So it helps us to reduce the function from one variable, two variables to just one variable. Now what can we do here? We can also do another substitution again, right? So we can say that, okay, let's u to be equal to r squared. So that's basically what we want to do here. When you do that, then we can see that r squared is approaching 0. So if we set r squared to be equal to 0, it means that u is going to approach 0. So now we go again and have limit u is approaching 0. Now u squared, r squared is equal to u. So this is going to be u sine of 1 over u. We're able to use polar coordinate to basically, check everything out and reduce the function to just one variable like this. So now here we can use squeeze theorem to work on this. So now here we know that sine is bounded by -1 and 1, right? So let's assume that theta is equal to 1 over u. So we are going to have -1 sine of 1 over u less than 1. So now we want to form this function here. So since we have sine of 1 over u, we want to multiply it by u so that we have the whole of this. So multiplying through by u is going to give us minus u less than or equal to sine of 1 over u, and then this is going to be less than or equal to u. I hope this is right. Of course, this is right. So now what is going to happen here is, now that we have, I think I need to multiply the middle by u, sorry. So the middle should be with u, and then we have this. Now what is going to happen here is, now that we have this in the middle, you see that this is attached with a limit. So we need to attach this one with limit, this one also with limit, and this one too with limit. So we are going to have limit u is approaching 0 minus u less than limit u is approaching 0 sine of u sine of 1 over u, then limit as u is approaching 0 of u. So what is happening here is, now I have this one here, the whole of this here, right? So now we can apply the squeeze theorem. So now u is approaching 0. So when I plug in 0 here, when I set u to be equal to 0 and I plug it in, I'm going to have 0 less than limit u is approaching 0, u sine of 1 over u less than 0 here. When I plug in, u is equal to 0. So left and right are the same. So we are going to say that limit as u is approaching 0 of u sine of 1 over u is equal to 0. And this implies that this is equal to 0. So that is how we can use the polar coordinate to work things out. It's very simple, very, very simple. Now let's look at this one too. Now this one to the same polar coordinate, because we have x squared plus y squared in it, so we can reduce it again. So when you write this often, you just remember it anytime you are working it out. So x is equal to r cos theta, y is equal to r sine theta. Then we have x squared plus y squared is equal to r squared. Do we need any other thing? No. So, okay. Now, what we just need is x and y is approaching 0, 0. So this implies that r squared will be also approaching 0. So because we have x and y here. So now we can write our limit this way. Let me put this guy here. Great. So now we can have our limit to be there. So now limit as r squared is approaching 0. I'm going to have 1 minus cos of r squared divided by r squared. Nice. Now do the same thing as we did for the first question. Let's u to be equal to r squared. So r squared is approaching 0. So u will also be approaching 0. So now we are going to have limit u is approaching 0, 1 minus cos of u divided by u. Now we have a theorem which says that limit as x is approaching 0 of 1 minus cos of x divided by x is equal to 0. And indeed, this is also going to give us a big 0 here. So this should be giving us 0. So, trig functions, trig identities, they are very, very important here. We need to remember them. Let's look at another interesting one. Okay, we have this one here. So same idea here, x is equal to r cos theta, y is equal to r sin theta, x squared plus y squared is equal to r squared. So the same thing here, r squared will be approaching 0, right? Great. So now we can now write this one as limit r squared is approaching 0. Now we cannot replace this one by r squared. Why? Because this is minus and this is positive. So we need x squared. So let's look for x squared from here. So x squared will be equal to r squared cos squared theta, and y squared will be equal to r squared sin squared theta. So this is very good information. So now we are going to have r squared cos squared theta minus r squared sin squared theta. Nice. Divided by r squared. Nice. Now we can simplify this and write this one as limit r squared is approaching 0, and then r squared cos squared theta minus sin squared theta. And don't forget, at the end of the video, I'm going to give you a trial question to also try your hand on. So now r squared will cancel r squared, and we are going to have limit r squared is approaching 0, and we have cos squared theta minus sin squared theta. We see that there is no even r in this function here, right? So we can say that, let's still go ahead and say that since this one is r squared, let's change it to u. So then r squared is approaching 0, u will be also approaching 0. So this one is going to give us limit u is approaching 0. There is no r here for us to change. So we are going to have cos squared theta minus sin squared theta. And this is going to give us cos squared theta minus sin squared theta. Most cases, if it is objectives, they can just leave the results in this and you check from the multiple choice whether you have this option. Or we can say that the limit does not exist. Why? Because the limit depends on theta, and it depends on the value of theta that we are going to get. So if theta is, let me assume 90, then cos 90 is 0, or cos pi on 2 is 0, and sin pi on 2 is 1. So this is going to give us minus 1 as the limit. Now if we change theta to pi, cos pi is 1, so it's minus 1. Minus 1 squared is 1, and this one is 0, so we are going to get 1. So you see, the first one was minus 1, this one was 1. So the limit is just going to change. So it means that this limit here does not exist depending on what we want to do here. But here we can boldly say that the limit does not exist, since this is like kind of theory stuff. Why? Because since the limit value, or the limiting value depends on theta. So the limit depends on theta. So no matter what you are going to do, you get different values for this question. Let's do the same thing here. I love writing this so that I will always remember it. So y r sin squared theta x squared plus y squared is equal to r squared. So what do we need? We need x squared plus y squared, which is great. We need another x squared plus y squared, but we need y is here, but we need x squared. So we need to find x squared using this. So x squared is going to be r squared cos squared theta. Nice. So now remember, x and y is approaching 0, so r squared should be approaching 0. So you are going to have limit r squared is approaching 0, sine of r squared divided by r squared plus, so this is going to be huge, r squared plus, so x squared here is this, and this is also y. So this is going to give us r squared cos squared theta times r sine theta. So let's try and simplify this and see what we are going to get from here. This is going to give us limit r squared is approaching 0, sine r squared divided by, here I can pull out r squared out and have r squared out, 1 plus r cos squared theta plus, no, times sine theta. So what did I do here? I just brought r squared out. So when I do that, this one will be left with 1, and I have 1 r here. So when I factor this one out, it will be just left with just the r cos squared theta and sine theta, which is this. Now what we can do here is also nice. We can decide to change our r, right? So this is what we can do here. We can say that, okay, fine. Let's u to be equal to r squared again. So u will be approaching 0 since r squared is approaching 0. So it means that this is going to give us limit u is approaching 0, sine u divided by u 1 plus. Now this is r, so we need to change r. Making r the subject here is going to give us r is equal to square root of u. So we are going to have square root of u, then cos squared theta sine theta. Beautiful. Now let's do something here. We know that if I have a over, let's say, bc, this is the same as a over b times 1 over c, right? So this is true, because I can multiply this one by this and have this, and multiply this one by this and have this one too. So this is the same as limit u is approaching 0, sine u divided by u times 1 divided by 1 plus square root of u cos squared theta sine theta. Why did I do this? I did this because I remember one theorem from trig limit that if x is approaching 0, of sine of x divided by x, this should be giving me 1. So I'm trying to make sure that I have that theory. So let's use properties of limit. I can write this one as limit u is approaching 0, sine of u divided by u times limit u is approaching 0, 1 divided by 1 plus root of u cos squared theta sine theta. Beautiful. So now this is going to give us a big one for this one. And this one we can do direct substitution to see what is happening here. So this is going to give us 1 divided by 1 plus. Now when I set u to be equal to 0 here, so we are setting u to equal to 0 here. When I put 0 here, square root of 0 is 0. So 0 times this is going to be giving us 0. So this is just going to be 0 here. So I'm going to have 1 times 1 over 1, 1 times 1, and this is a big 1. Wow, this is also very nice and beautiful. So we had 1 for this. So polar coordinate, you are working with it, you are trying to do some small manipulations, and then you see how you can go about the whole question. Question 1, I should have used limit definition to, verify that this is indeed 0. Now, I'll do question 1 using the limit definition, and let's see how, if you have sine function. Maybe don't forget you said you do question 1a using limit definition, right? So we will use limit definition to do question 1a2 and see if we are going to get it right to be less than epsilon. So let's look at e. Now e, we want to use polar coordinate because we have something squared, right? But because this is like y minus 1, we want to do change of variable so that we can do that. So here I can set, okay, let's x equal to s and y equals to, no, y minus 1 equals t, right? That's basically what I'm doing here. So this implies that, now remember, x is approaching 1. So if x is approaching 1, sorry, x is approaching 0, then what will happen to s? S will also be approaching 1 because we are saying that, okay, so let me change this one so that we are setting s to x and t to y minus 1. So here, if x is approaching 0, it's like putting x is equal to 0, then y s2 is going to be 0. Now here, this also implies that if y is approaching 1 from here, then when I set y to be equal to 1 here, this will be 0. So here, t will be approaching 0. Nice. So it means that now we can change our function to limit s and t approaching 0, 0, because everything is going to 0 from here. And then now we are going to have s squared t squared divided by x squared plus t squared. Now, if you are not good with this one, after you have done something like this, you can rewrite it again and write it this way. If you are not good with using the s and t, you can also write this one as, okay, you are just doing something like, it's not consistent, this is not right, because, but we want to do something again, say s is equal to s and y is equal to t, which is no, right? But we want to make sure that our function is in terms of x and y, then work with it. But you can also use s and t to work with it. Anyhow, the way you want to do it is going to be right. So that if I'm doing that, then this is going to be limit again, x and y is approaching 0, 0 of x squared y squared divided by x squared plus y squared. Then we can use the polar coordinate. But we can also use the polar coordinate using s and t. But don't forget, s is with what? X, and t is with y. So using polar coordinate here, remember s is equal to r cos theta. So s here is going with s. So this guy changes to s. And then y is equal to r sine theta. And y is going with t. So this one changes to t. So it means that, remember, x squared plus y squared is equal to r squared. So this is going to be s squared plus t squared is equal to r squared. So that's what we are going to get from here. So now, since st is approaching 0, 0, then r squared is also going to approach 0. So this is going to give us limit r squared is approaching 0. Then this x squared and t squared, we need to look for it. So this is going to be r squared. X squared is equal to r squared this, and t squared is going to be r squared sine squared theta. So let's do substitution. So this is going to be r squared cos squared theta times r squared sine squared theta divided by r squared, because this here is thus. Now let's try and simplify this. So this is equal to limit r squared is approaching 0. I can factor, I can multiply. This one is multiplication, so I cannot factor. So this is just the same as r to the power 4. So when I multiply this to this, that's what I'm going to get. And then I'm going to have cos squared theta sine squared theta divided by r squared. We can cancel r squared to have limit r squared is approaching 0. Then this is r squared sine squared theta sine squared cos squared theta sine squared. So we do the same thing as we do. Let u is equal to r squared. R squared is approaching 0, so u also will be approaching 0. So this is going to give us limit u is approaching 0, and this is going to be u cos squared theta sine squared theta. So here we are going to set u to be equal to 0, plug it in, and we are going to have limit, plug it in, and this is going to be just 0. So we don't need to do anything, because this is constant, right? So when I plug in 0 here, everything here goes to 0. This is so much beautiful, right? Using polar coordinate to do this. And as soon as we have gotten this one like this, we can use the epsilon delta definition to also do that. But this one, we are just doing the evaluation. But when I finish, I'll do question 1a again using epsilon delta definition. Now we have an exponential function here. What can we do? Same thing. X is equal to r cos theta, y is equal to r sine theta, and then x squared plus y squared is equal to r squared. I hope you are enjoying it. Give me a like, give me a comment, and let's share the videos for others to also join and grow our community. So now what can we do here? The same thing as x and y. So you see, the more I'm solving, I'm getting used to whatever I'm writing now. So any question that I do, I just don't take too much time working on it. So now this is going to be equal to limit r squared is approaching 0. Now this is going to be e to the power r squared minus 1 divided by r squared. Let's do the same procedure again. Let u to be equal to r squared. R squared is approaching 0, so u should be approaching 0. So what is going to happen here is we have a limit, u is approaching 0. Now r squared is the same as u minus 1 divided by u. Nice and beautiful. Now when you plug in u is equal to 0, look at what is going to happen. So when I do that, this is going to be e to the power 0 minus 1 divided by u divided by 0. And e to the power 0 is 1 minus 1 divided by 0, and this is 0 over 0. So here, for us to solve, we can use the L'Hopital's rule, right? Because it follows one of the rules. Let me say rules of L'Hopital's rule, right? So we can use this. So since this is 0 over 0, we can use the L'Hopital's rule. So what does the L'Hopital rule say? So I'll put the equal to sign here, and I'll put LH on it, telling us that we are using the L'Hopital's rule. So this is going to be limit u is approaching 0. So L'Hopital's rule says differentiate the top, and when I differentiate it with respect to u, I have the same thing because this will be 0, and when I differentiate this with respect to u, I get the same thing. And then when I differentiate u with respect to u, I get 1. So simplifying this is going to be limit u is approaching 0 of u to the power this, and now we can do substitution again, and this is going to give us 1. Beautiful. So this here is going to give us 1. So when you see the question will be scaring you, but if you know the right procedure or if you know what you are doing, you should be much confident doing it, and then also doing it very, very fast, right? So that is the idea of when you practice. Now let's look at this one too again. The same thing again. So you see the way I write, I don't get tired of writing because I know that the more I write the formulas and these things, the more I remember. So this is going to give us r squared here. And then now let's do substitution. X and y is approaching 0 again. So r squared should be approaching 0. So now this limit here will be equal to limit r squared is approaching 0, e to the power minus r squared, and then sine of 1 divided by r squared. So same procedure again. Let u to be equal to r squared approaching 0, u should be approaching 0. So what are we going to get now? Limit u is approaching 0, e to the power minus u, sine of 1 divided by u. Now when you plug in u 0, because this is going to be 0, it's going to be crazy. So here we can use the squeeze theorem. So minus 1 less than or equal to sine theta is bounded by this. So I'll change theta to 1 over u because that's the angle that we are using here. So minus 1 less than sine of 1 over u less than 1. So that if I have this here, I need to multiply it by this. So when I do that, I'm going to have minus u less than or equal to e this sine of 1 over u less than or equal to e to the power this. Then now I have this in the middle, which is the same as this. So I need to take the limit through. So limit as u is approaching 0 of minus this is less than or equal to limit u is approaching 0 minus this sine of 1 over u less than or equal to limit this is approaching 0 e to the power this. Nice and beautiful. So now we can work on the left and the right. Now when I plug in 0, this is what we are going to get. Minus e to the power. So when I plug in 0 here, minus times 0 is still 0. So this is going to be 0. Less than or equal to, let me just copy this. Great, let me put it here. And the same thing to this one too. This is going to be e to the power 0. Now e to the power 0 is 1. So this is minus 1. And if I copy this one again, and this is going to be 1. So the left is minus 1, the right is 1. So the limit does not exist. In short, this does not exist. So this does not exist. So we are going to say that this is D and E. So when you see me using D and E, I mean does not exist. Yeah. So that's what you are going to get for this particular question here. Now let's look at this nice and beautiful question also here. So the same idea, let's go again. X is equal to R cos theta, y is equal to R sin theta, x squared plus y squared is equal to R squared. And we are going to need x to the power 4. So let's do that. X to the power 4 is going to give us R to the power 4 cos 4 theta, right? So that's what you are going to get from here. So let's move on to say that x and y is approaching 0. So R squared should be approaching 0. So limit as R squared is approaching 0, we are going to have R squared divided by square root of R squared plus, so I need to extend this. Now, x squared plus y squared is giving us this, and this is this. So we are going to have R to the power 4 cos 4 theta. Can we simplify this? Oh yes, we can simplify this and have R squared is approaching 0, R squared divided by square root of. So here I can factor R squared out and have 1 plus R squared cos squared cos 4 theta. So now this is also going to be R squared divided by. So now remember that if I have square root of a, b, this is the same as a times square root of b, right? So I'm just going to take square root of R squared, and it's going to give us R, and then I'll have 1 minus R squared cos 4 theta. Okay. Now we can cancel one of the R and have R squared minus R squared is approaching 0. R divided by 1 minus R squared cos 4 theta. So now let's change it now to let U to be equal to R squared. This implies that R is also equal to root of U because we have R here. And then we know that R squared is approaching 0. So U should be approaching 0. So this will be equal to limit U is approaching 0, and R is the same as square root of U divided by square root of 1 minus U cos to the power 4 theta. Now what can we do? Let's try and plug it in and see what is going to happen. So let's do direct substitution first. So set U to be equal to 0. Square root of 0 divided by 1 minus 0 times that is going to be 0, square root. Top will be 0 divided by square root of 1, and 0 over 1 is going to give us 0. So we are interested in making sure that the top, the denominator is not 0. So this is going to give us 0. That's beautiful. Now I think this is the last question, then we get to the trial questions. And then I said I'm going to do a using limit definition, then we are done with this. So let's look at what we can do here too. Okay, let me simplify this once more and see what I'm going to see here. X, y is approaching 0, 0. When I factor x out, I have x squared minus, okay, we cannot do anything impressive there. But okay, fine, we can still do that. and then y squared divided by x squared plus y squared to the power 3 on 2. So this is what you are going to get. Don't forget, x is equal to r cos theta, y is equal to r sine theta, x squared plus y squared is equal to r squared. And here, x and y is approaching 0, 0. So r squared should be approaching 0. And we will need x squared y squared because we don't have something like x squared plus y squared. So we need x squared is equal to r squared cos squared theta. And we will need y squared, which is equal to r squared sine squared theta. So now this is equal to limit r is approaching 0. Oops. R squared is approaching 0. Then x is r cos theta. Let me shift this one down small. And then in the parentheses, we have x squared, which is r squared cos squared theta, minus 3 times y squared, which is r squared sine squared theta, all divided by x squared y squared this. So x squared plus y squared, which is going to give us r squared 3 over 2. Let's try and simplify this before we think about u. So r squared approaching 0. Now this is the same as r cos theta. We can, I think here too, we can factor r squared out. So we can say that r squared out, so making it r cubed. So when I factor r squared out and multiply by this, I get r to the power 3 cos theta squared minus 3 sine squared theta. Now this 2 here can cancel this. So this is like you have 2 times 3 over 2. This is the same as 3. So the denominator is going to be x to the power r to the power 3, and we can cancel the r out, and we are going to have limit r squared is approaching 0. So when I cancel out, I'm going to have cos squared theta minus sine squared theta, and we are going to have this one to be okay. So let's assume that let u is equal to r squared. R squared is approaching 0. U should be approaching 0. So this is going to be limit u is approaching 0. There is no r here, so we are just going to have this minus 3 sine squared theta. And limit of a constant, because it does not depend on u, is the same as a constant. So this is going to give us this minus 3 sine squared theta. So what are we saying here? We are trying to say that now this is, we are going to say that it does not exist. I think I've explained one of them already, because the value of theta, if it changes, the limit value too changes. So we are going to say that this does not exist. Now let me go and do question 1a using the epsilon delta definition. Then I'll give you the trial question for you to also do. So let's just do it quick. I want to show you how to manipulate this function to using the epsilon delta definition. So let's go. Now that we know that, so the same question again. Now that we know that this is 0, so we suspect that this is going to give us 0. So that is the idea here. Then using the limit, using the epsilon delta definition. Now, guess what we can do here? So given epsilon greater than 0, there exists delta. I said delta can depend on epsilon greater than 0 such that whenever absolute of x minus 0, which is the same as absolute of x, is less than delta, and absolute of y minus 0, which is the same as absolute of y, is less than delta, then what happens? Then absolute of x squared plus y squared sine of 1 over x squared plus y squared minus 0 is less than epsilon. So now let's see how we can figure out this. So we have x squared plus y squared, and then sine of 1 over x squared plus y squared. Absolute, absolute, okay, minus 0. This one should be the same as. So I just want to copy this and then put it here. So when I subtract the 0, I still have this one here. Now, impressive. Now, remember that if I have absolute of AB, this is the same as absolute of A, absolute of B. So if this is true, then I can write this one as this. This is the same as absolute of x squared plus y squared, absolute of sine of 1 over x squared plus y squared. Nice. Now we know that sine is bounded by minus 1 and 1. So sine theta minus 1 and 1. And this is the same as absolute of sine theta less than 1. So this can be written as this. So sine is bounded by 1. So it means that this one here, if I set theta to be equal to 1 over x squared plus y squared, then this will be bounded by 1. So this is going to give us this. This is going to be less than or equal to absolute of x squared plus y squared times 1, because this is bounded by 1. And this is the same as absolute of x squared plus y squared. Now that we have x squared, y squared, we need to focus on getting absolute of x, absolute of y to be less than delta. So we can use triangle inequality. So this is the same as absolute of x squared plus absolute of y squared. And this is the same as absolute of x squared, absolute of y squared. Now this is less than delta, this is also less than delta. So this is less than delta squared plus delta squared. Now we choose delta to be less than 1, and this is going to give us less than or equal to 2 delta, right? So when I plug in, or let me say, this is the same as delta plus delta when I choose it to be that. And this is going to this. So when I plug in 1 here, this is going to be 2. This is also going to be 2. But when I pick anything less than 1, remember, delta is greater than 0. So there's no way we can choose something like 0 or minus. And I think because this one is even squared, and this one is not squared, so we can never choose negative. So it should be 0, delta, and less than or equal to 1. If I pick 1 over 2, 1 over 2 here plus 1 over 2 here will be 1. But 1 over 2 squared, 1 over 2 squared is going to give us 2 over 8, which is the same as 1 over 4. And 1 over 4 is always less than 1 over 2. So that is the idea here. So now that we have this one, we can choose. Now that we have this one here, we can choose delta to be equal to epsilon divided by the coefficient of delta here, which is 2. And this will be 2 epsilon over 2, and this is equal to epsilon. So now choosing the minimum by choosing, or let me write this one, what is happening here. We have absolute of x squared plus y squared, sine of 1 over x squared plus y squared. This is less than epsilon. So we are saying that by choosing delta equals the minimum. So here we need to choose the minimum because we made 2 choices. We chose this and we chose this. So we need to choose the minimum on this. So by choosing this, we can see that whenever absolute of x is less than delta and absolute of y is less than delta holds, then So I think let me just bring this one here. Then this one is true. So by choosing the minimum of this, we have this. So hence, we have verified that limit as x and y is approaching 0, 0 of x squared plus y squared in parentheses sine of 1 over x squared plus y squared is indeed equal to 0. So we have so many functions that we can use epsilon delta to work it out to get the right solution. So now let me give you the trial question for you to try to leave your final results in the comment section. So this is the trial questions. Try and solve it and leave your answer in the comment section. And as I said, now in the next video, now we are going to talk about using iterated approach to solve limit question. So see you in the next video.